Okay, so we're going to take a look at this 4-5 worksheet. So this is logarithms. So the first thing we want to check is to see if we can get these numbers to the same base number. So in this case, I have a 2 and I have a 1 over 64. So with practice, you guys will start to recognize certain numbers to different powers. And in this case, we can get 1 over 64 to a base of 2. So you can use your calculators to kind of help you out with this stuff, but I know that 2 to the negative 6, 2 to the 6 would be 64, so that means that 2 to the negative 6 would be 1 over 64. So I'm going to change these both to bases of 2, so then I have 2 to the negative 6 here. Now, since I have the same base of 2, I can just take their exponents and set those equal to each other. So I would have x minus 1 equals negative 6. Then we would just add that 1 over to finish solving for x. So we have an x equals a negative 5 here. On this guy, you can quickly check your work kind of in your head, but you can always use your calculators to help check your work as well. So negative 5 minus 1, that's negative 6, and with my calculator, I can check that 2 to the negative 6 equals 1 over 64. That must be correct. All right, this guy we have 1/4 and we have 8, so I can get those both to bases of 2. So I know that 2 squared is 4, so that must mean that 2 to the negative 2 must equal 1 to the 4th. I'm going to give that guy a base of 2. And I also know that 8 can be changed to 2 to the 3rd power. So then we will have 2 to the 3rd to the x minus 1. From our exponent properties, we should know that a power to a power, we are going to multiply them. So I'm just going to multiply these. So then we have 2 to the negative 2x. Equals 2 to the 3x minus 3. Again, now since we have both bases of 2, I can just take their exponents and set those equal to each other. So we have negative 2x equals 3x minus 3. And then it's just simple algebra from here. So we're going to subtract 3x, subtract 3x. Then we would have negative 5x equals negative 3. So we're going to divide both sides by negative 5. So x equals 3 over 5. And again, you can use your calculator to check your work for you. That would work as well. All right, with this guy, you should be able to recognize a 5 and a 125. So I got 1/5, so I know that 5 to the 1st is 5, so 5 to the negative 1st must be 1/5, x minus 2. And then 5 to the 3rd is 125, so we're going to change that to 125 to 5 to the 3rd, x over 2. Before we set those exponents equal to each other, we're going to have to distribute. So then I have a negative x plus 2 equals 3x over 2. Alrighty. Then, again, it's just simple algebra from here, so I'm going to multiply both sides by 2. So we have negative 2x plus 4 equals 3x. Add that 2x over. And we have 4 equals 5x. Divide by 5. Divide by 5. X equals 4 over 5. All right, with this guy, I see a decimal, so I don't even really want to deal with that. So I'm just going to change the form and give these guys both logarithms. So we're going to bring that negative x out to the front. Negative x log 1/2 equals log 1.6. To get that negative x by itself, I'm going to divide by log 1/2. And I'm just going to leave that as is. So we're going to have negative x equals log 1.6 divided by log 0.5. And then the last thing we would have to do to get this x by itself would be to divide by a negative 1. So I'm going to go to my calculator. We're going to turn this on. And I'm just going to type in log 1.6. Close that parenthesis, divided by log 0.5, and I'm going to click equals, and then I'm just going to click divided by -1, and then click equals again. And in this assignment, we're going to round to the nearest thousandth, so I'm going to look at that 8, look next door, we don't add one more there, so our answer here is x equals 0.678, about, because we're never going to get those exact. So that would work for that one. Alright, looking at this next one here, again, I got some decimals I'm working with. Now, using the log form on this one, adding that log to or giving that log to both sides, you can use that for any method. Even if I wanted to use that for this method, I absolutely could have. It just made my life easier by finding those same bases. So in this guy, I'm going to do the same thing I did for that last one, where I'm just going to bring that exponent out to the front, give them both logs. 14.5. Now I got to get this x minus 1 by itself, so I'm going to divide both sides by that log. So then we're going to have x minus 1 equals log 14.5 over log 1.5. And then to finish solving for this x, I would just add 1 to both sides. So in my calculator, this is what I'm going to type, and I'm going to press equals, and then I'm going to put plus 1. So we're going to do log 14.5, close that parenthesis, divided by log 1.5, and I'm going to click enter, and then plus 1, enter. So again, the thousandths place, so we're going to look over. So we have x is about 7.595. We're going to solve this next one the same way. So that first thing we do is going to bring that exponent out to the front. So we have x over 2 plus 1 log 3 equals log 12.2. We're going to divide by log 3. So we have x over 2 plus 1 equals log 12.2 divided by log 3. Now, to get this x by itself, the next thing we would do would be to subtract that 1 and then multiply both sides by 2. So I'm going to make my calculator do all that for me. I'm just going to clear it. We're going to click log 12.1, close that parenthesis, divided by log 3, enter, subtract 1. So then we're going to subtract 1, enter, and then we would have to multiply both sides by that 2. So now we're going to do times 2, enter. And, I think my answer key might be a little bit wrong, because we're going to round again to the nearest thousand, so that guy's going to go up 1. Did I type something in there wrong? Log 12. Oh, 12.2. That's where I messed up. Okay, we're going to try again. So log 12.2, close that parenthesis, divided by log 3, enter, minus 1, enter, times 2, enter. There we go. So we have x is about 2.554. All right, moving on to that next page. Now, since we have both logs of 3 here, what we can do is we can take those and just set those pieces equal to each other to solve for that x. So we have 7x equals 2x plus 0.5. We're going to subtract that 2x, subtract 2x, 5x equals 0.5, divide by 5, divide by 5, x equals 0.1. Alrighty, these next ones I feel like are where we didn't really like things going on. So when this side has a log and this side doesn't, here's what we have to do. In order, if we wanted to get rid of that log and solve for this x, we can take this side and make this 1 plus x over 2. but then we have to set that equal to this number to that power. So we have 2 to the 4th now. Now, again, we can just solve this like simple algebra. So we have 1 plus x over 2 equals 16. Subtract that 1, subtract that 1. X over 2 equals 15. Multiply both sides by 2. And x equals 30. Alrighty, for this guy, when we are subtracting logarithms, what we're actually doing with them is we're actually dividing, right? So when I divide 5x by 15.5, I will end up with log x over 3.1 equals 2. Now remember, when we don't have that number written down here, we assume that it's a 10. So just like we did over here, we're going to take x over 3.1 equals that imaginary 10 to the 2nd power. So then we end up with 10 squared here. So we have x over 3.1 equals 100. Multiply both sides by 3.1. And x equals 310. Alrighty, for this next guy, what we're going to do, again, we're going to kind of solve it the same way that we have been. So I'm going to take this x to the 4th, kind of break it off, equals 5 to that power. So we're going to have 5 to the 2.5. I showed you guys how to do this on your calculator the other day, but now I will show you again, because to solve this one for x, we need to take the 4th root of these answers. So I'm going to go into my calculator, I'm going to click 4, because I'm finding the 4th root. Then I'm going to click math, and then we want to get down here to this 5, so I'm just going to click 5, and it set it up for me. So that's taking me the 4th root of whatever I type in here. Now what I type in here is going to be 5 to the 2.5 power, which is, let me just make sure, yep, 2.734 is what we're going to round that to. So x is about 2.734. Okay, this next one. Again, when I am subtracting with logarithms, we should actually think about dividing them. So I'm going to kind of come over here and take x divided by x over 100. When we divide fractions, we keep change flip. So this will be x times 100 over x, which is just 100. So now we have log 100 equals x. Again, this number here is like an imaginary 10. So if I want to take that 100, I'm going to say 100 equals that imaginary 10 that's not written, 10 to the x. And you guys should be smart enough to know this. That would mean that x must be 2. Okay, this next one we didn't really have an example like this in our notes, but we can always just add that log 3x to the other side. So then I'm going to write it with the logs being on the left. Then I would have log x over 12 plus log 3x equals 2. All I did was add that log to the other side and then rearrange how my equation was written. So now that we're adding logarithms here, we're actually going to be multiplying these two pieces. So I should end up with x squared over 4, because we've got 3x times x, which is 3x squared over 12. Just simplify that 3 over 12. So now I have an x squared over 4. So we've got a log x squared over 4 equals 2. There's no number written here, so I'm assuming that it's a 10. So I'm going to take x squared over 4 equals 10 to the 2nd power. Then I'm going to multiply both sides by 4 because I know that that's going to be 100. So we have x squared equals 400. Take the square root. X equals plus or minus 20, but in this case it's just going to be that positive 20 because we're working with logs here. Alrighty, now we're back to seeing if we can get them to both the same bases. So we have a 3 and a 9. You guys should know off the top of your head that we can get 9 to a base of 3. So we've got 3 to the 4x minus 1 equals 3 squared to the x plus 1. One thing we really have to remember with these ones is we have to distribute that 2 to this grouping. So now we will have 4x minus 1 equals 2x plus 2. And then just simple stuff from there. Subtract that 2x, add that 1. So we have 2x equals 3, divide by 2, divide by 2, x equals 3 over 2. Alright, this one was 7 and 22. I cannot get those guys to the same basis, so I'm going to bring that exponent out to the front, give them logs. So we have 4x minus 3 log 7 equals log 22. We want to get this piece by itself, so we're going to divide by that log 7. So then we have 4x minus 3 equals log 22 over log 7. My next steps would be to add that 3, and then I would divide both sides by 4 to get that x by itself. So this is the order we're going to be typing into our calculator. So we're going to hop in here. I'm going to click log 22, close that parenthesis, divided by log 7, enter, plus 3, enter, divide by 4, enter. So we have about 1.147. Alright, this next one, we're not going to do that next one, so don't worry about that guy. Alright, on this one, we're subtracting logs again, so when we are subtracting logs, we should be dividing them. So we have log 4x plus 8 over 3 equals 2. That's an imaginary 10 there, so I'm going to take 4x plus 8 over 3 equals 10 to the second power, which is 100. Now we got simple math going on here. Multiply both sides by 3. So then we have 4x plus 8 equals 300. Subtract that 8. 4x equals 292. And that must mean that x equals 73. Alright, flipping over to the back here, we have a log 5. So I'm going to make this left side 3x plus 7 equals 5 to the second power. So 3x plus 7 equals 25. Subtract that 7, subtract that 7. 3x equals 18. X equals 6. I've got a 6 and a 36, so I can get them both to bases of 6. So I have 6 to the 3x minus 7 equals 6 squared to the x minus 1. Again, distribute that 2. So we have 3x minus 7 equals 2x minus 2. Subtract 2x from both sides, and I'm going to add that 7 as well. So then we have x equals 5. Okay, for this next one, again, we are multiplying logarithms here. So we're adding logs, so when we add logs, we should be multiplying. So when we have two binomials multiplied together, we're going to FOIL. So I'm going to end up with, if we come and FOIL, I would have log 35. X times x is x squared. Outer is plus 5x, inner is plus 3x, so we have plus 8x. And last is plus 15. And that equals 1. So I'm going to make this left side x squared plus 8x plus 15 equals 35 to the first power, which is just 35. Now we are going to be solving this by subtracting that 35 over. So then we have x squared plus 8x minus 20 equals 0. We're going to have to factor this, so we need to find two numbers that multiply to give me negative 20, but added give me 8. And those two numbers are 10 and 2, and that must be a negative 2. So this guy would factor into x minus 2, x plus 10. So x will equal 2 and negative 10, but that negative 10 is not going to work for us, so we have x equals 2. We're not going to do this number 8 as well, so cross that one out. So then I cannot get 2 and 15 to the same base number, so I'm going to bring that exponent out to the front. 2x minus 2 log 2 equals log 15. I'm going to divide both sides by that log 2. So then I have 2x minus 2 equals log 15 over log 2. To solve for this x, I would then add 2 and then divide by 2. So that's what I'm going to type into my calculator. So we're going to hop over here. We're going to type log 15, close that parenthesis, divided by log 2, enter, plus 2, enter, divided by 2, enter. And we end up with 2.953, about. Alright, this guy does not have a log over here, so I'm going to take this 7x plus 8 equals 4 to the third power. So 7x plus 8 equals 64. Subtract that 8. 7x equals 56. X equals 8. Alright, this next guy here, we're subtracting again, so we should, oh, this is the same exact problem, totally forgot, don't worry about it. Alright, we're going to do number 12, just like we did number 7 up here. So we're adding logarithms, so we should be multiplying. So I have log 28, I'm going to FOIL this out. So I have x times 2x, which is 2x squared. Outer is minus 5, inner is minus 6. So I have minus an 11x, and then plus 15 equals 1. So now we're going to take this trinomial, 2x squared minus 11x plus 15 equals 28 to the first power, which is just 28. I'm going to subtract that 28 over, so we have 2x squared minus 11x minus 13 equals 0. Now we are going to have to use the box method for this one. We cannot just go straight to our x. So we do jump straight to our x, but we cannot jump from our x into factoring it. So remember, factoring trinomials that have a coefficient with x squared, we have to multiply these two first to figure out what they would multiply to give me. So I need two numbers that are going to multiply to give me negative 26. And added give me negative 11. The only two factors of 26 besides 1 and 26 are 13 and 2, and it must be a negative 13 in order to get to that negative 11. Now we can jump to our box method, where I'm going to create my box. I'm going to put 2x squared in the top left. I'm going to put negative 13 down here, and then I'm going to take negative 13, give it an x, and then I'm going to take that 2 and give it an x. Now we're going to factor these separately. So going up and down, I can take a 2x out of both of those terms. Out of these terms, I can take a negative 13 out. Going across, the only thing I could take out is an x. And the only thing I can take out this way is a 1. So that must mean that this trinomial factors into 2x minus 13 and x plus 1 equals 0. Now, I taught you guys a kind of trick way to figure out what x equals from this. That must mean that x would equal 13 over 2, a positive, because we changed that sign. So positive 13 over 2, and then a negative 1, but that negative 1 doesn't work for us. So 13 over 2 must be our answer.